Okay, so this is the 2016, just a year gone by, Leave Insert higher level coordinate geometry question. So we're looking at a number of points here, A to F. All of the coordinates were given in terms of their height in elevation and plan view. Apart from point F in the elevation, you're missing point F, so you don't know where it is, but you do have it in plan view. Alright? So with that in mind, part A of the question is simply asking you just to find all the coordinate points that are given and to join them accordingly. So I've pre-completed that part of the question. The second part of the question, part B, then is asking you to determine the dihedral angle between the planes ABC and ABD. Okay, so I'm just going to make a note of that. So we're looking for the dihedral angle between ABC and ABD. So looking at those two planes, they have 2 points in common, point A and point B. So the line of intersection is already found. It's the line going from A to B on both planes. And in elevation, you'll see that as that line there. And in the plan view, you'll see it as this line here. So that's our line of intersection. So when we have our line of intersection, I'm just going to label it in elevation and in plan view. That makes this question a lot easier in terms of finding the dihedral angle. So, as usual, what we do is we go to our plan view, we get our line of intersection, we match the angle of it. So I'm using my adjustable here. And we have to look perpendicular in the first auxiliary to that line of intersection. Now I'm just using pen so it'll show up on the camera for you. So I'm going to look out perpendicular to it. So that means creating an x1, y1 line, which is parallel to that angle. I'll just label that x1, y1. And I need to bring out my points perpendicular to that angle, like so. So I'm talking about the plane ABC, so I'm going to bring out all 3 points at the same angle, and do likewise with ABD. So that will involve bringing point D out, like so. Alright, now I'll just extend those down so that they go far enough. I'm in the first auxiliary, so as usual I'm going to go back 2 views to transfer my measurements. So that would mean if I'm in the auxiliary here, if I go back 1 view, it'll bring me to the plan view. If I go back a 2nd view, it'll bring me to the elevation. So the heights from this view and the elevation are going to transfer down to this first auxiliary. So I'm looking for the heights of A, B, C and D. The simplest way of transferring heights is just to use your compass. It's the quickest method, it's the most accurate method. So we have A, B and C have the same height. C. And finally, point D is the lowest of the 4. So I'll just label those up. We have A, B, C and D, and we'll draw our 2 planes. So ABD is one of the planes and ABC the other plane. Now what we have is a true length of the line of intersection. So what we now need to do for the second auxiliary, and in order to find the dihedral angle, is to look through that to get a point view. So that's going to involve another auxiliary through the line AB. Now the adjustable mightn't just work for me because the drawing is, or the view is too low on the drawing sheet. So I'll use my sliding set squares in this case. So I'm looking through the angle AB to get a point view of that line. So I look straight through it. I'll create an x2, y2 line. I'm going to keep my views tight enough to each other, because that way I don't need to take datum lines or anything like that. Can't be avoided sometimes. And everything must come out at that same angle. So if you're using adjustable, or if you're using sliding set squares, just be as accurate as possible. So D comes up at the same angle and C comes up at the same angle. Again, I'll just run over that in pen so you can show up on the screen a bit clearer. So that's my x2, y2 line, which is perpendicular to the angle I'm looking out at. And I have A, B, C and D all brought up to the second auxiliary. I'm going back 2 views as always, so go back 1 view, I'll be in my first auxiliary, go back a second view, I'm in my plan view. So the measurements are going to come from the x1, y1 line back to the plan view, and they're going to transfer to the second auxiliary. So D is the closest. You could, if you wanted, take a datum line, and you could use D as your base. Mightn't just have to in this case, it'll probably fit in. So I have D. A and B are the same distance, and they're along the same line, so that's where your point view comes out of. And point C is the furthest away. Like so. Okay, so I'll label those up so you get quite an obtuse angle. Get into the habit of actually measuring in degrees what the dihedral angle is. It doesn't always ask for it in the question, but you're better off just to do it, just in case there is marks going for it. There is a degree of margin of error they'll give with this, so I'm going to mark that as 169 degrees. And if you look up the marking scheme, it'll be in or around that, 2 or 3 degrees out, you're okay. So that's the dihedral angle found between the planes ABC and ABD. You're given a line of intersection because A and B are in common. In other questions, you mightn't be given both points on the line of intersection. You might have to find 1 point, you might even have to find 2 points, and there are other videos of that up if you need to look back on those questions. Part C then of the question is asking you to draw the elevation and plan of a horizontal line on the surface DEB, and with this you have to determine the true angle of inclination of surface DEB to the horizontal plane. That is essentially, when they ask for a horizontal line in order to get the true angle of inclination, what they're essentially looking for there is a straight line. It's just another way of phrasing it. So we're going to look at the surface DEB in elevation, which is this surface here. And we have to draw a horizontal line which will lead us to be able to get the true angle of inclination. What they're looking for is a straight line, and any of you that are familiar with the roads question in section C will understand when you draw a straight line, you need to draw the straight line so it'll cut across the surface and it's horizontal. So if we have 3 points that we can draw it from, if we drew it from B, it'll be horizontal but it won't cut across the surface. If we drew it from D, again it'll be horizontal but it won't cut across the surface. So the best location for it will be from point E. I'm just going to draw it in red and as a dotted line so it is highlighted. That's my straight line, what they're looking for. Now we must bring that down to plan view and replicate that line in plan view. So the line goes from point E. I already have point E in plan view. The other end of the line is here on the surface DEB. So I'm going to drop that down until I find where it's located in plan view. It's on the line DB. So when I drop that straight down, I'm looking for where it cuts the line DB. And I can join that back to point E, and that's the straight line in plan view. Now in order to get my line of, my true inclination of that line, I now have to look straight through it, a point view of that straight line. And what it'll do is if I bring the other points up at the same angle, it'll give me what angle that surface DEB is pitched at. So I'm going to use my adjustable here again. Sometimes students get confused. Does it matter if you look down this way or if you look upwards? It doesn't make any difference. It's the same view. You're just looking in from a different side. So I'm going to draw upwards, but if you drew down towards the bottom of your page, you would still be correct. So point view of that straight line, bring it straight up, look straight through it, bring the other points up at the same angle. It's an auxiliary view. So you need an x1, y1 line. So we put that in. Heights, we're going back 2 views. Go back 1, I'm in the plan, go back 2, elevation. So DEB, I have to find the heights of those 3 points in elevation and transfer them up. And if I'm accurate enough, when I join the 3 of them together to draw the surface, they should join into an edge view. They should all join up into a straight line. So D is this one here, E is in the middle, and B is up the top. And if I join the 3 of them together, yeah, I get an edge view of it. Now the question does ask to indicate what inclination that surface has to the horizontal plane. The horizontal plane is the ground. The ground in this auxiliary view is the x1, y1 line. This is an edge view of the surface, so they want to know what's the angle between those 2 lines. So what you can do is, in order to indicate it, you can take your surface and you can just extend it down until you can actually put in a measurement in terms of degrees. Or equally, you can take the ground line and just slide it up until it would touch the surface, and again indicate the angle like so. So that's the way I'm going to go about it with this question. So there's my x1, y1 line. I'm going to slide it up. I'm just going to put in a broken line there to indicate. I'll just mark there parallel in case there was any doubt in what I'm doing. And I'll put in the measurement, so I'm getting about 52 degrees of an angle of inclination. Again, there's a margin of error there, so if you check the marking scheme, it'll be within 2 or 3 degrees of that figure. So that's part C of the question complete, the angle of inclination. The last part of the question is to do with this missing point F in elevation. Now this often comes up in section C, so any students that have well practiced what would have been known as the old roof question, it's a surface geometry question, you'll often see this coming up where you're missing a point, and what they will do is they will give you the measurement of the dihedral angle between the 2 surfaces. So the 2 surfaces we're talking about are BDE and DEF, and they have a line in common in plan view. We have all our points obviously in plan view, so it doesn't seem like there's a problem, but obviously point F, we don't have it in elevation. So what they do is they give us the dihedral angle, and in this case they give the dihedral angle as being 170 degrees. So what you do is you go about the normal drawing that you would do if you didn't have the dihedral angle. What would you be looking for? The first thing you'd be looking for is the line of intersection. You have the line of intersection between those 2 planes, and we'll just label it. DE is the line of intersection, so we label that in elevation and we label it in plan view. So that's my line of intersection. As normal, if we have a line of intersection, we look perpendicular to it for our first auxiliary. So I'm going to go out towards the left hand side of my page because I have space that way, and I'm going to look perpendicular to that line of intersection, DE, and I'm going to bring all my 4 points in total out perpendicular like so. So that's B, D and E and F. The next stage will be to get my heights, so I can draw those points. So I have an x1, y1 line in place. My heights are coming from the elevation, so I'll get the height of the points that I know. So I can definitely get the height of B, and I can follow it up and mark it off. So that's point B. I have the height of D, so again I'll follow it up, mark it off. So that's the height of D. I have the height of E, so that allows me to draw my line of intersection, DE. I don't have the height of F. We don't know what the height is. That's what we're trying to find out. So we just continue on as we would. So D goes to B, to E, back to D. And remember, this is my line of intersection, the line D to E. F is missing. But I do know that point F has to be somewhere along that line, which I brought up perpendicular, because because that's where it originates from. It has to be somewhere there. I just don't know exactly where yet. If we're doing a dihedral angle question, the next stage would be, once we have a true length of the line of intersection, we would look straight through it in order to get a point view. So we'll move on to that stage of the question. Again, I need to do sliding set squares this time around. So we'll be looking down straight through it. We would get an x2, y2 line at this point. And we'll bring down our other points. Now in this case we only have one other point, which is point B. So I have an x2, y2 line in place. I have point B coming down, I have point D and E coming down. Normally, go back 2 views, get the measurements and transfer them here. So, D and E are going to have the same measurement. Now, I might in this case just take a datum line or measuring line because the distances are getting very far away from each other. So I'm going to take that x1, y1 line and I'm just going to slide it back as far as, let's say, point B will be my base. So that means point B will be here at a height of 0. So I've just taken that line and slid it down because that's all empty space, just to keep this tight down here. D and E are going to be the same measurement, so measure back to that datum line for D and for E. So they'll just be a point view. So there's an edge view of that surface. And we're given the dihedral angle, which is 170 degrees. So what you can do is, with your protractor, you can measure 170 degrees based off that line. So that means the dihedral angle will be coming out like so. I'll just do it as a broken line for now. So that's the direction that that dihedral angle comes out at, 170 degrees. Now, let's just think back to what we did just before we measured that angle. These heights came from back 1, back 2. They came from the x1, y1 line coming back to the plan view. I have a distance back to point F. So what I can do is, I can take that distance and measure it up in the second auxiliary. And if I was to cut a height line across here, point F has to be somewhere along that height line because that's the height of it transferred through the auxiliary views. So when I drew my dihedral angle of 170 degrees, what you'll find is if you take a height line across for point F, it'll cut that angle of 170 degrees, which means you've located point F. That has to be point F. Now, how is that an advantage? Well, if I have point F now in auxiliary 2, I can bring it back up to auxiliary 1. And if you remember, point F was coming up this direction, so what will happen is it'll cut over itself. So we'll be able to locate it in 2 views. So we're sliding it up. Like so. So we'll just transfer that up. Cuts across point F, which is coming out this way. That means that point F has to be in that location. Now that means I can go ahead and I can actually just complete that first auxiliary. Now if you remember, the heights for the first auxiliary came from the elevation. So if I now have the height of point F in that first auxiliary, I can now transfer that back up to the elevation. So that means I know the height of point F. Point F is located here in the plan view. So if we just brought that straight up, mark a height, that completes the full drawing for point F. And that allows me to complete my elevation, my original elevation. And that'll often come up in, like I said, section C as a surface geometry question. So that's the 2016 coordinate geometry higher level question complete. Good bit in it, but that type of question is going to get a lot more common, I'd imagine.